Discovery Alert: 172 possible planets. We live in the astronomical era of the haunting of exoplanets. When astronomers first started looking for other planetary systems, they were surprised by the huge number of exoplanets they found. They also realized that such exoplanets were quite different from the ones we are used to, talking about our solar system. There are, of course, Jovian exoplanets or Neptunian exoplanets, meaning that they have something in common with Jupiter and Neptune, for example. But we discovered a lot of planets that are out of this world. And I don't mean literally, I also mean in a figurative way, because a lot of them own strange properties and features. The variety of exoplanets seems not to come to an end. As of today, we know there are planets the size of Jupiter orbiting so close to their host star that we don't know how it's possible they ended up there. It would be like having a Jupiter orbiting closer to the Sun than Mercury does. Can you imagine that? However, today we are talking about a brand new discovery about exoplanets. Basically, we found 172 candidates and 18 possible multi-planet systems. Keep watching the video to get to know more about this amazing discovery and how it could change our understanding of the universe. We have a new catalog of exoplanets. Exoplanets can be cute or weird. They could have low surface temperatures, or maybe they could be hot as an inferno. But one thing is sure, they are planets orbiting other stars. This new catalog includes 172 previously unknown planet candidates and 18 multi-planet systems, meaning that if our suppositions are correct, we have at least 208 new planets, all of them coming from the same discovery. How was this discovery possible? Did humans manage to discover more than 200 planets in just one survey? Well, it actually happened that a fully automated exoplanet detection system sifted through years and years of data from NASA's famous Kepler Space Telescope and yielded a jungle of discoveries. The results were there, waiting for them to be read out in order to reveal the secrets of exoplanet formation and to sharpen our picture of their many varieties. Scientists just had to go through that data and analyze it. But first, let's talk a bit about the Kepler Space Telescope, for those of you who don't know anything about it. The Kepler Space Telescope was, and we say was because it was shut down in 2018, a space telescope launched by NASA to discover Earth-sized planets orbiting other stars. Named after astronomer Johannes Kepler, the spacecraft was launched on March 7, 2009 into an Earth-trailing heliocentric orbit. After 9.5 years of operation, the telescope's reaction control system fuel was depleted, and NASA announced its retirement on October 30, 2018. Designed to survey a portion of Earth's region of the Milky Way to discover Earth-sized exoplanets in or near habitable zones and estimate how many of the billions of stars in the Milky Way have such planets, Kepler's sole scientific instrument is a photometer that continually monitored the brightness of approximately 150,000 main sequence stars in a fixed field of view. This data was transmitted to Earth and analyzed to detect periodic dimming caused by exoplanets that cross in front of their host star. Only planets whose orbits are seen edge-on from Earth could be detected. Kepler observed 530,506 stars and detected a lot of planets. According to NASA, more than 2,800 have been confirmed and more than 3,250 candidate planets await confirmation, including the latest bunch of 172 candidates we are talking about. Hundreds of these candidates were actually detected during Kepler's second mission. In November of 2013, a new mission plan named K2 Second Light was presented for consideration. K2 would involve using Kepler's remaining capability, photometric precision of about 300 parts per million, compared with about 20 parts per million earlier, to collect data for the study of supernova explosions, star formation, and solar system bodies such as asteroids and comets, and for finding and studying more exoplanets. In this proposed mission plan, Kepler would search a much larger area in the plane of Earth's orbit around the Sun. Celestial objects, including exoplanets, stars, and others detected by the K2 mission would be associated with the EPIC acronym, standing for Ecliptic Plane Input Catalog. Before talking about this new catalog, let's see some Kepler highlights in order to better appreciate the job done by this mission and the contribution it gave to science. Before the launch of Kepler, most of the planets we knew about were really big planets like Jupiter, but Kepler was way more sensitive and we started finding smaller and smaller planets. Thanks to Kepler, astronomers discovered planets smaller than had ever been discovered before, and there were a lot of them, indicating that our Milky Way galaxy is actually full of planets. Crazy worlds that we didn't predict, things that we hadn't imagined. We find planets orbiting so close to their parent star on the star-facing side has temperatures in excess of that required to melt iron, that is 1,811 Kelvin. These planets have an entire hemisphere that's like a liquid ocean, but it's not an ocean of water, it's an ocean of molten rock. Kepler also showed us the existence of planets that are orbiting not one but two stars. That is, if you look in the east, you would see not a one-star rise, but two. Imagine how good and weird at the same time the sunrise would be on that planet. Kepler told us that the most common types of planets are different from the ones that we are used to in our solar system, and that maybe we live in a special star system, which is quite unique. These worlds are intermediate in size between the Earth and Neptune, but we're not exactly sure what they're made of. There are also some things that before Kepler we didn't know, and now we do know. For example, planets are ubiquitous. We can find them almost everywhere. Planets are diverse. The most important thing Kepler showed us that small, potentially rocky worlds orbiting in the Goldilocks zone of their stars exist, and at that distance you could have liquid water pooling on the surface of the planet, capable of supporting life as we know it. If many planets are similar in size to the Earth, it might be that we have a chance for life as we know it elsewhere. As Thomas Zurbuchen, a Swiss-American astrophysicist, now Associate Administrator for the Science Mission Directorate at NASA, said, searching for life elsewhere is one of the key themes that drives our science portfolio, and at the center of that is Kepler. New missions like the Transiting Exoplanet Survey Satellite, TESS, and the James Webb Space Telescope will build on Kepler's success and take our search for life to new heights. We had an overview of what Kepler was able to do over the past years. Now let's talk about this new discovery, this new catalog of exoplanets. The new catalog drawn from Kepler's K2 observations includes some truly bizarre planets and planetary systems. In one system, EPIC 249559552, about 650 light-years away, two sub-Neptunes, smaller versions of our own Neptune, orbit a yellow-white sun-like star. The planets are locked in a kind of gravitational dance known as orbital resonance, with the inner planet making 5 orbits for every 2 by the outer planet. In another system, some 3,500 light-years distant, EPIC 249731291, a star not unlike our Sun, hosts 2 gas giants, a bit smaller than Saturn, orbiting their star so closely that their atmospheres are perpetual infernos. Placed in our solar system, these 2 giants would be inside the orbit of Mercury, the closest planet to our Sun. 2 giant planets in such a tight orbit around their star could reveal important clues about how planets form and possibly how they migrate from one orbit to another during the long lives of planetary systems. Why is it so important to have catalogs of exoplanets? Well, the answer is quite simple. Catalogs allow scientists to conduct some sort of demographic studies of planets. If you have a limited number of planets, let's say a number of 10 planets, you can imagine that other planets are not so different from the ones you know, and you can proceed with statistical studies about them. But if you have 1,000 planets, the statistical studies will be much more accurate, because you are taking into account a lot of different features and quite diverse planets. Identifying populations of exoplanets with shared characteristics, how frequently they occur in the galaxy, and their relations of these many planet types to one another is one of the most important goals of astrophysics. Moreover, such an exoplanet census could reveal patterns in how planetary systems form and how they change over time, including gas giant planets migrating from distant orbits into closer orbits around their stars. Some planet types might be found more frequently around certain types of stars, such as red dwarfs or yellow stars like our Sun. This means that by studying exoplanets and their formation, we could infer something about the formation of our solar system, and thus we will have a better understanding of the universe we live in. This new catalog could also tell us something about planetary formation in our galaxy. For example, where are the vast majority of planets formed? Are they located in the disk or outside of the disk of our galaxy? Kepler's first mission focused on a single patch of sky above the galactic plane, the narrow disk-like region where a greater abundance of stars orbits the center of the galaxy. The second mission, K2, was confined to the ecliptic plane, where the planets in our system orbit the Sun, but we're able to observe a series of sections around the plane instead of a single patch. The distribution of planets above the galactic plane and in different directions could tell us that certain planet types, say small rocky worlds like our own, are more plentiful or rarer in different parts of the galaxy than others. This could facilitate our job in the finding of new forms of life on other planets. It is a really exciting perspective, isn't it? That's all for this video. Thanks for watching, everyone. What do you think about the Kepler Space Telescope, and what's your favorite planet so far? Let us know in the comments below. See you next time on the channel.